On Friday, April 13th, 2029, a dark object wider than the Eiffel Tower will race toward Earth and enter the realm of our satellites. It will pass closer than many geosynchronous satellites. From parts of Earth, it may look like a moving star crossing the night. Apophis will not strike Earth in 2029, but its passage will be so close that our planet may physically reshape the asteroid. The story began in June 2004, when a telescope in Arizona detected a tiny object moving differently from the stars around it. Astronomers observed it for only 2 nights before weather and technical problems interrupted the search. Then the object disappeared into darkness. 6 months later, another observatory found it again. With new measurements, computers began projecting its path decades into the future. The first calculations produced a frightening result: a 2.7% chance of impact in 2029, high enough to alarm the world. For a brief period, Apophis became one of the most dangerous known objects in the sky. Every new observation could change the prediction. Its discoverers named it Apophis, the Greek name for Apep, the ancient Egyptian force of chaos, darkness, and destruction. The name sounded ominous, but predictions depend on measurements, not mythology. Optical telescopes and planetary radar began narrowing the asteroid's future path. Older photographs revealed where Apophis had been before its discovery. That extra history removed the possibility of an impact in 2029. Questions remained about later encounters in 2036 and 2068. Scientists continued measuring tiny changes that accumulate across millions of kilometers. By 2021, radar observations had refined the orbit enough to rule out an Earth impact for at least the next 100 years. Apophis has a mean diameter near 340 meters, while its longest dimension may reach at least 450 meters, roughly the scale of the Eiffel Tower. Radar suggests it may be elongated or double-lobed, perhaps resembling a rough peanut assembled from ancient fragments and loose material. It is an S-type asteroid, built mainly from silicate rock with metallic nickel and iron, a relic left from the early solar system. Apophis formed from material more than 4.5 billion years old, before planets had finished assembling around the newborn sun. Today, Apophis does not spin smoothly. It tumbles end over end, completing one main rotation roughly every 31 hours. Before 2029, it circles the sun in slightly less than 1 Earth year and crosses Earth's orbital path as an Aten-class asteroid. The 2029 encounter happens because Earth and Apophis arrive near the same region of space at almost the same moment, but not at the same point. At closest approach, Apophis will be about 32,000 kilometers above Earth's surface, less than 1/10 of the distance to the Moon. Its path will carry it closer than the altitude of many geosynchronous satellites, the machines that appear fixed above Earth's equator. The asteroid will not fill the sky like a giant rock. To unaided eyes, it should resemble a bright point moving steadily among the stars. Weather permitting, the flyby may be visible without telescopes from parts of Europe, Africa, and Asia across Earth's eastern hemisphere. Earth's gravity will pull unevenly across it. The near side will feel a slightly stronger force than the far side. That gravitational torque is expected to alter the asteroid's tumbling, possibly speeding one motion, slowing another, and changing its orientation forever. The encounter may trigger asteroid quakes, loosen boulders, or send small landslides down slopes that have remained undisturbed for millions of years. How much the surface moves will reveal whether Apophis is solid, deeply fractured, or a loose rubble pile held together by weak gravity. Earth is about to perform a planetary-scale experiment that no laboratory could reproduce, using gravity to probe an asteroid without touching it. Robotic observatories worldwide will track its path, brightness, and rotation before, during, and after the encounter to detect even tiny changes. Planetary radar will transmit powerful signals and measure their returning echoes, revealing shape, distance, orientation, and surface features invisible to ordinary cameras. As Apophis rotates, Its brightness will rise and fall. Those repeating patterns can expose its shape and reveal changes caused by Earth's gravity. ESA and JAXA plan to launch Ramses in 2028, sending a spacecraft to meet Apophis before it reaches Earth. Ramses is designed to observe Apophis before the gravitational encounter, creating a detailed baseline of its shape, motion, and surface. Two small CubeSats will extend the investigation, studying released dust and probing deeper clues about the asteroid's hidden internal structure. Ramses will accompany Apophis through the close pass, watching the precise moment Earth's gravity begins changing the ancient object. Cameras will search for fresh scars, displaced rocks and clouds of dust, evidence that a brief encounter rewrote a surface billions of years old. After the flyby, NASA's OSIRIS-APEX will rendezvous with Apophis and examine the transformed asteroid for about 18 months. Its cameras, spectrometers, and laser altimeter will map the post-encounter surface and compare it with everything recorded before the close pass. OSIRIS-APEX will later descend close to the surface and fire its thrusters, blasting loose dust away to expose material hidden underneath. As the dust clears, instruments will examine material protected from space weathering, offering a glimpse beneath Apophis's ancient exterior. Apophis is safe, but the next large asteroid may not be. Understanding its structure could determine whether a future deflection mission succeeds or fails. A solid body, fractured rock, and rubble pile cannot be treated in the same way. Apophis will teach us how to recognize the difference before time runs out. The 2029 campaign will test the entire warning system: detection, tracking, international coordination, spacecraft response, and communication with the public. For an object of this size, such a close and safe encounter may occur only once every 5 to 10,000 years. For a few hours, an ancient object will pass through Earth's neighborhood while telescopes and spacecraft record every tremor, shadow, and moving grain. Apophis will miss Earth, but its passage may reveal how asteroids break, shift, and survive, and how we might stop one that does not miss. On April 13, 2029, nature will bring a planetary defense laboratory to our doorstep. The question is, will we learn enough before the next warning?